Balancing oxidation reduction reactions of acidic solution. First, we have to set our overall reaction into separate half reactions. Our first half reaction will be H2S yields S, and our second half reaction will be NO3 minus yields NO. Next, we have to balance for all the elements except for oxygen and hydrogen. In our first half reactions, both of our S's are already balanced. In our second half reactions, both of our N's are already balanced. Next, we have to balance for oxygen. In order to do this, we have to add water to the side that is most oxygen deficient. In our first half reaction, we don't have any oxygens, so we don't have to add any water. In our second half reactions, we have 3 oxygens on this side and 1 on this side. So we have to add 2 waters to this side. So we have NO3 minus yields NO plus 2H2O. Next, we have to balance for our hydrogens. In our first half reaction, we have 2 hydrogens on this side and none on this side. So we have to add 2 hydrogens as seen. In our next half reaction, we have 4 hydrogens on this side. To balance the hydrogens out, we have 4 hydrogens on the other side. Next, for each half reaction, balance the charge by adding electrons. The electrons are added to the more positive side. In our first half reaction, we have H2S yields S. So that means we have 2 hydrogens plus 1 sulfur, and there's no charge. Hydrogen always has a plus 1 charge. So we have 2 plus S equals 0, S equals -2. For our other element, S is in its free state, which means it has a 0 charge. We went from a -2 to a 0 charge, meaning we lost 2 electrons, and this goes on the product side. In our second half reaction, we have NO3 minus yields NO. We have 1 nitrogen plus 3 oxygens equals a -1 charge. N plus 3, oxygen always has a -2 charge, equals -1. So N plus -6 equals -1. Now we have to add the -6 over, and N equals +5. The other equation, NO, equals 0. N, as just stated, oxygen always equals -2. So this means that N equals +2. We went from +5 to +2, meaning we gained 3 electrons. And this goes on the reactant side. Now that we have found how many electrons were lost and how many electrons were gained, we write it back into our half reactions. So this becomes 2 electrons plus H2S yields S plus 2H plus. In our other equation, we have 4H plus NO3 minus yields NO plus 2H2O plus 3 electrons. Next, we have to multiply one or both half reactions by a whole number so that both half reactions have the same number of electrons. So with our first reaction, we will multiply by 3. And our second reaction, we will multiply by 2 so that our electrons are equal. So we have 6 electrons plus 3H2S yields 3S plus 6H plus. And I'm going to go ahead and write down the other half reaction below it. We have 8H plus 2NO3 minus yields 2NO plus 4H2O plus 6 electrons. As we can see, we have the same number of electrons in both of our half reactions. Now we have to add both half reactions. The electrons will cancel, as with some of the H pluses and H2Os. So we add our half reactions, our electrons cancel. Also, we have 8 hydrogens on this side and 6 on this side, so this reduces down to 8H plus, reduces down to 2H pluses. Now bring down everything that's on your product side and your reactant side to get the final answer, which will be 3H2S plus 2NO3 minus plus 2H plus yields 3S plus 2NO plus 4H2O. And this is how you balance oxidation reduction reactions of acidic solution.